Just, we'll see what happens. Who knows? Okay. 6.8, I basically talked to you about standard form of an equation. Okay, can somebody tell me how is an equation written standard form? You can give me an example one, or you can give me the kind of basic formula for that. But give me one. What is the standard form of an equation? Yeah, go ahead.
Y equals mx.
That's actually not the standard form.
Is it the ax plus
Yes.
by equals c?
So ax plus by equals c, where a, b, and c are real numbers. Okay. They actually don't represent anything in the graph. Not a thing in the graph.
It's just an equation.
It's just what we call standard form of the equation. Okay. I am not a fan of it. They always teach it to you. You need to recognize that. You need to know that you can make it into a slope-intercept form very easily. I gave you 2 ways to do that. One way was to find the x-intercept and the y-intercept. When you're finding the x-intercept, you want a number for x. We want x equaling a number, so we make y equal 0. When we're finding the y-intercept, we want y to equal a number, so we make x equal to 0. Okay, so let's say we take the problem. 3x minus 4y equals 12. I'm doing this so it's very easy. Okay, I don't want a lot of fractions here. Okay, so if I put y in as 0, I have 3x minus 4 times 0 equals 12. Goes away, so x is equal to 4. So my x-intercept is the point 4, 0. Okay, that's the easy way of finding it. Okay, the next one is just the opposite of that. I want the y-intercept where it crosses the y. At that point, x is 0, so I get 3 times 0 equals, minus 4y equals 12. If I divide by negative 4, I get y equals negative 3. So that gives me the point 0, negative 3. Okay. If I want to put it into y-intercept, we now have b, because b is the y-intercept. So if I have the y-intercept now, I know what b is in my equation, so I put in negative 3 there. I wouldn't have to have the plus sign there. Okay. And it's very easy to find the slope, because we have 2 points, and all I have to do is find the rise over the run for these 2 points. So from 0 down to negative 3, it went down 3. That's the change in y. And I'm going to do it over the change in x. Well, from here to here, I went down 4. A negative 3 over a negative 4 is a positive 3/4. So now I know my slope is 3/4. So that's a very quick way and simple way to change it into slope-intercept form. You just find the intercept. Then if you have these 2 points, you can find your slope. And now you have slope-intercept form. Okay. You can also do it by solving for y. Okay. Solving for y is a little bit more of a pain because we have to move things that have variables in them, and a lot of people get anxious about that kind of stuff. Okay. But if you went with this, 3x minus 4y equals 12. The first thing I'm going to do is get rid of 3x on both sides. So I get negative 4y equals, and I'm going to write the negative 3x first, plus 12, as long as I take the signs with them. Okay. So all I did was subtract 3x on both sides. On this side, I put the subtract 3x first, and then the 12. I divide by negative 4. That gives me y equals negative divided by negative is 3/4 x. 12 divided by negative 4 is minus 3. Look at that.
I like that way.
Doesn't matter. I don't care which way you want to do it. Both of them work. I'm just showing you can find out from both ways. This, to me, is a much easier form of the equation. It is called the slope-intercept form. It's the form that I like to use, and it's also, when we get into functions, it's the form we use for functions. Okay, so when we start talking about functions, this is the form that we use, because in a function we always say y equals. Or we put that fancy terminology of f of x in there. F of x equals, which f of x is really y. It's just a different way of writing it. Okay. So that's where we looked at it. And so that's basically the idea of 6-8. Just introducing you to that standard form so that you can know it, you can see it, you can understand that, yeah, it's a line still, okay, but it's just written in a different form than our slope-intercept. Okay, 6-7. 6-7, what we are looking at is something that they do all the time. And I want you to understand basically what they do. We are first going to kind of do it by hand, and then we're going to look at how you could do it on the computer, because this is something that is done in statistics. Okay, so this section is called the best fit line. Okay, that's what we're going to call it right now. It's going to have a different name in just a minute. But in statistics, when we're looking at two different variables, say we want to see how much a population of animals is growing, and we take and we find in the year 2000 it was this amount of animals that we could found that were, say, rabbits. Okay, they have estimation ways to estimate. Every year they kept a track of how many rabbits there were, and the population was slowly growing. Okay, what they do when you have two different items like that over the years and the number of rabbits, okay, we make what is we plot that kind of data on a coordinate graph, just as if we were going to plot anything else like a point. Okay, then what we do is usually, if it looks like it's going up in a line, we try to come up with a formula for that line so we can make predictions. And that's how they make predictions on a lot of stuff. That's how they predict how warm it might be in the oceans because of global warming. That's based on some sort of line that they've calculated. Okay, that is a prediction that they may say about the populations of certain cities. If it's been growing linearly, then they will maybe make a prediction of what it is. It's also a prediction of maybe what your score is going to be on how much time you study. Okay, your test scores. Usually the number of hours you study helps increase the test score. And so that's another thing that they can maybe make a prediction on. That's a very individual prediction, I'll just tell you that. They try to lump it in for all people, and it really doesn't work. Okay, so I actually had a student that looked that up and found a study about it, and there were just a whole bunch of questions they had about the study, so it didn't really prove much of anything. But to do this, right now I want to use some graph paper, so I'm giving everybody a piece of graph paper. And then we are going to look at We're just gonna do the one in the book on page 368. So if you could all turn to page, oh, you have some? Okay. You can turn to page 368. Maybe you have some. Okay. So on page 368, we're talking about in the years, what was the life expectancy of a person, okay? So over the last almost 100 years, it was from 1930, we're in 2025, so it's not exactly 100 years. But these were some different life expectancies that they came up with. And those expectancies are actually based on when people die. So they're calculated. This is based on everybody. In real world senses, guys usually die younger than women. So the life expectancy for a man is actually younger than the life expectancy of a woman. Okay, did I say that backwards? I don't know what I said. Anyway, part of that reason is because we sometimes have younger guys that die because they are a little bit more prone to do dangerous things at a young age. That pulls down the life expectancy. Okay. So I don't think there's anything that women do a lot different, except for we may not have as many women die young because they don't go out and maybe crash the cars or do. It's really, that's why men's life or car insurance is much higher than girls at the age of 16 to 25. It's because young men are more careless drivers. I'm not saying that on everybody. Case by case, it's different. On average, they're more careless. And so that also reduces our life expectancy. Yes.
If you look at the table going from the 40s to 50s, you
Yes.
can see like a really big jump
Yes.
in life expectancy.
Why do you think that was?
World War II?
Yes. Yes. So we can figure out why some things occurred. World War II, we lost a lot of people. That really reduced our life expectancies. Okay. So then as that ended, life expectancies grew. Okay. So let's go ahead right now on your graph. I want you to make.
And it also jumped from 70 to 73, which marked the end of the Vietnam War.
Correct. Okay. It only goes up to 2000. I'm going to have us I'm going to look up 2010 and 2020 and see what those are so we can add them. So go ahead. You're basically making a graph
How many people died?
like down in the lower right-hand corner. Notice, this is one thing I want to help you see. If you want to zoom in, usually we always start at 0, 0, okay? But when we're looking at something that doesn't start at 0, so life expectancy never started at 0, okay? We would probably never have a year where our life expectancy of humans is 0 years. That just wouldn't be practical. Does not make sense. That means you don't even get born. Okay, we don't have any of that. Okay, so our life expectancy starts at about 59 years of age. So you can start wherever you want, maybe 55, whatever you want to go by. When you're looking at this, one way to do it, so this is something you need to know how to do. So you need to know if it will fit on your graph. This goes from 59 up to 77. So it goes from 59 up to 77. That is what, 18? Is that right? Did I do my math right? Yes. That's a distance of 18. Now, what you need to know is you need to have it on here so that you can cover at least 18 years. Okay. Now, if that means you go up by 2s, that's fine. If you go up by 5s, that's fine, because it will go over that, right? Go up by some standard number. I mean, you can go up by 3s if you want. It's just not as easy to read things off of it. And so go up by a standard number. So if I went from 55 up to, let's say, 80 by 5s, all of those will be included, right? Does that make sense? Because my 55 would be below my lowest number. My 80 would be above my highest number. So that's all I really need to have is from 55 to 80 here. I mean, I technically only need to be from 59.7, but I'm not going to put a 0.7 on here. Okay. And I could go by 2s, I could go by 5s. It's really up to you how you do that. Okay. If you wanted to start at, so this is by 5s. If you wanted to start at doing a similar thing at 58 and go up by 2s to 78, that would cover everything too.
Can you also search up the numbers for 1920?
1930 to 1920,
Yeah, because
it doesn't have a 1920.
I know it doesn't, but
Yeah.
I want you to look it up so I can.
Oh, I'm going to add that, yes.
Yeah.
Is this just for the US or is this global?
I do believe, let's just see.
India, 5.
No,
If it was India, it would be a different story.
There's so many people in India.
Wasn't it just last year when it broke like
this is the United States.
5 billion?
No,
This
there's
is
not
the
5
life
billion.
expectancy
It's like
of
2
people in the US.
3.
Okay, so go ahead, start making your graph.
Wait, is there 10
This
billion?
goes up by 10s, so I would just automatically do by 10s here. Again, you do not have to start at 0. You could say 1930, 1940. Okay, whatever the smallest one is, 1930, start at 1930. Okay, so those are kind of the things when you're looking at fitting data, you kind of want to zoom in, and this is how we say that we're zooming in. Okay, we know this is where our 0, 0 is right here. Okay, we're zooming in from there. Okay, I will now add, so while you guys are doing that, I'm going to look up, and hopefully my internet is working. So I'm going to look up 2010's life expectancy for the US and 2020's life expectancy, so you can add that in.
3 2 points that are.
You want me to help you with that part?
I don't know. I drew a line.
Okay, I'm not sure that that line goes through like equally balanced. That looks like it's really below most of the points.
What if mine's
So
a
you need to
fraction?
get it.
Above,
I
in the middle.
What do you mean a fraction? For your slope?
Yeah, what if it's like a negative 6.3 over negative 40?
Well, that's positive then.
Yeah.
Okay. How did you get 6.3 if you used whole numbers?
Oh, yeah. Sorry about that part.
Just wondering.
I'll just clarify.
Okay, that's good.
Yeah. 10 years of lifespan.
No, that's not years lifespan, it's in year 10. Will this be? Okay.
The year 10.
There you go, we had it.
Okay. Caroline. I probably messed it up somehow.
Well, no, don't think that.
I beat you.
I beat you up.
Wait, that's not the
Yes,
answer, is it?
sir.
Oh, no.
Yeah,
What I gotta do now?
Oh,
Oh, no.
What'd you do?
I gotta do not 60, 70.
Yeah, find B. And so
Parentheses.
then you're gonna say y
40,
equals by
no.
20 over
40.
x.
Oh, wait, and then after we do that.
So keep solving.
I don't like the life expectancy that time.
What's your
That's
equation?
Abraham.
Oh, you're still working, okay?
Oh my gosh.
Oh my gosh.
Trump owned this ruin.
Oh my gosh.
Let me
See
see.
that kind of
Okay.
Let me
stuff.
see.
I don't want
I
that
actually
kind of
didn't
line, I want
look
a
up
straight
these.
line.
Let me see. Let me see.
I'm saying that you're trying to eyeball the
That's
best
not
straight
calculated since
line.
Fran attempted that.
No, I think
Okay,
it's
so
real.
what you're trying to do is get one that goes, like, has part of the numbers above and part of the numbers below. So that's what you're trying to look for, it's like an equation like that.
I've played these games before.
I played these games before.
Okay, look at that.
Right, and then you're gonna subtract.
Yeah, that's practically the same thing.
Or is that
Oh my
negative?
God.
No way.
No, it's going up here.
You know, I think.
I just wanna make sure.
This end.
Is that your signature?
No, Trump really signed this, look.
Okay, you're so full of stuff.
Can I keep this?
My, it's worth $1 million.
Probably is.
Some person would probably buy it for a ridiculous amount of money.
Okay,
Like, definitely like $1.
Max, do you have
insane
your
amount of
line? What
I
is it?
do. Y is equal to 5/20x.
Can somebody reduce 5/20?
1/4.
Oh,
yeah,
thank
1/4,
you.
my bad. Plus negative 422.5.
Grayson,
I got y equals 1/4 x minus negative 1900.
1900?
Yeah.
Huh, okay.
Probably just math wrong, but. Y equals 7/40 x.
7/40?
Uh-huh.
Okay.
Minus.
Are you still calculating?
I think
Just
40.
calculate it. Okay, let's see.
I don't know what to do.
Are you
now.
guys done? No,
Y
okay, you're still working.
equals mx plus.
So find your slope. Find 2 points on there. Remember, we were finding 2
Like
points.
the smallest and the largest.
Oh wait, hold on. never
No,
mind.
the points it goes
Hold on,
through.
no, mine isn't 1900. It's negative 422.5.
Did you guys use the
my
same
numbers are
numbers?
the exact same.
Oh, yeah. So
Oh,
I did do it right, no way.
It's possible that we can get the same, exact
what's your,
same. What did you get?
got
negative 430.
430.
Right.
Not a good enough line.
Mine looks like this.
Wait, did you pick 1990 and 2010 for your two numbers?
No, I picked 1970.
Negative something.
Oh yeah.
Oh,
I
bye,
got it.
Grayson.
Yeah, we're
Oh,
gonna
bye,
head out for an
Grayson.
appointment. Thank you.
Hopefully it records, so you can watch online. I'm having terrible luck, the internet's going in and out. And so I don't always get a good recording to submit, but Grayson's pretty smart, so I think okay. I would like you to be able to go on though and do it online on the computer, so.
Yeah.
I can always send you,
Now we're gonna have to do one of these for each one, probably.
no, we're not.
What's the equation to find the slope again?
You take your 2 points and find the rise over the run, the
I don't
change
get
in
what you
y
mean
over
by
the
finding
change in
2
x.
points.
Yeah, but the equation, what was it?
Y1 minus y2 over x1 minus x2. That's just a long way of saying change in y. What is the change in y over the change in x?
I totally forgot.
What I just said?
Yeah. I don't know.
Y
Y1 minus y2
Over.
minus, or divided by, sorry.
You need help, Matthew?
I got the
Yeah,
same
I don't know
thing as
what
Max
she's
and
saying with
Good.
the fourth.
I think I'm just.
Did you do?
I don't understand what I have to do for the lines.
Okay, so you got that, and so basically what you're looking for is
And Caleb?
one that looks like it's about the line, but it's also a solid. So see how this one is what year is this? It's
90.
that's 90. This one's 90.
Yeah, 90.
Or okay, what's this one? 1990. Yeah.
Okay.
Okay, so according to the
Good
line,
question, that one.
and
It's a little bit different.
75, so 1990 is equal to
1/7 is a
75.
little different than 1/4.
This is your point
Four,
one, or
let's
so
see.
right 1990.
He's kinda close to
comma,
1/4
or
here,
do
cause
comma,
10 over 40 would
75.
be 1/4, but he's a little bit lower. This is quite a bit
Okay,
lower.
this is point
I'm trying
one.
to think, let me see what you did on that.
So you put parentheses around it if you want.
Okay.
And then you need to find another one that is close to the line but is also
Okay,
a
so you
solid
have
number.
these points,
So like look,
this is a difference
that one
in.
looks good, right? Because it's like directly on your line.
70, yeah.
Okay, so it'd be 1970.
Huh.
And then
Oh,
what year does
you
it say it
picked
is?
for your line, what,
70.
that, okay.
Oh,
I
no,
can
this
see
is
you
the
raised it up
amount
higher
of
than
things,
most
and this
people.
is
Most
the,
people would want to know that.
you said,
So-
what year is it?
Wait, what
This is
year?
fine.
This is the year, right?
Yeah,
This is fine.
So then this is the life expectancy for
Yeah.
70. So it would be 70. It'd be 1970 and then 70. And then you remember how to get the slope off of this?
Mason, did you get yours?
Which is
You
why,
just subtract
yeah.
the two of them basically. Okay. So on this side it would be 5.
5, and then this side. Would be 30,
20.
20?
Great, I'm
just
just gonna finish this
So,
one and we
five.
can have two parts, hopefully this one will at least